this time it's recording much more smoothly compared to last time, so I don't know why it's doing better. It is recording just fine, I think. We'll go ahead and get started. I recorded the other class, the earlier class, which is cisp300 in a different way. So I'm just going to compare the two different methods and see which one works out better. Oh, I kept going to the wrong one. Address. All right. Well, I want to share something kind of funny from my perspective, with you. How many people know who's Damon Antos? He's our department chair, and you might get him in your next class, cisp360. He's one of the two professors teaching cisp360. So he gets a lot of my students, because this class feeds into cisp360 directly. And yesterday he came to my office and said, you know what, some of my students complain about you. And I go like, oh, that's not good, And he said, and I asked him, what are they complaining about me? Did they say that they didn't learn what they really should be learning in the class? They didn't learn enough, in my class? He said, no, they just said that you're too hard. And I go like, okay, well, that's okay with me, not a problem. I think some people, say that I teach things that they do not think is necessary to know in programming in this class. And that's okay with me. Yeah, I didn't tell Damon, and I said, I didn't tell him, but I was thinking at the time ago like, okay, I can maintain my reputation. All right, so we're going to kind of stay on the kind of softer topic today with developers and other people who are needed in the development of information systems. Remember last time we were building a house? Okay, you have a property along Highway 1. It's a very nice view to the ocean and stuff like that. And we already talked about the architect, right? The architect is the person who would talk to a client, who owns the property, and find out what the requirements are first. Okay, I want to entertain up to 30 people at a time. I want my bedroom to oversee, the Pacific Ocean. Have a really good, possibly panoramic view of the ocean and stuff like that. So those are requirements. Okay, the client may not even have a visual, imagination of what the house may look like, but these are the requirements. Okay, being able to entertain 30 people is one of the things that the architect can take and turn it into more solid numbers and designs. Okay, number of rooms, number of bathrooms, how big the kitchen needs to be to entertain or to serve food to 30 people. The size of the dining room, even the size of the gas pipe. Okay, can be somewhat determined by the number of people that you want to serve, because gas pipes come in different sizes. I think ½ inch is the bigger one. Do they come in smaller sizes? Does anyone know? Yeah, so they have different sizes. Okay, you don't want to entertain 30 people from a gas stove that is only designed to serve a family of 4 by design, right? Because half of your guests will be starved to death. And they'll be opening the fridge and start to eat the meat in the refrigerator raw, because they have been waiting for too long and get their meat or their food. All right, so the architect and the client will interact multiple times to consolidate. Okay, this is my initial design. I will put your guest rooms over here. Your bedroom is going to be over here. This is the layout of the guest rooms. Maybe along the long hallway, with bathrooms, distributed. Maybe you don't want it. You don't like the design. Maybe you want the guests to be in a separate building, okay, a separate structure, okay. So you can tell the architect, and say, okay, I kind of like my privacy, when I sleep. So I want the guests to be in a different structure when I entertain the guests, and I want these two structures to be connected by a covered hallway or whatever. Okay, so these are all interactions. Okay, the architect will give you a basic design, on the blueprint or just sketches, and you look at the sketches and go like, well, this is kind of what I want, but I don't really like that part of the design. So you can refine your requirements. Okay, you can refine the design, and after a few times, the architect will be able to come up with a blueprint and possibly a 3D model, so that you can actually walk through the house, as if the house is already built. Okay, they have software that can do that now. So that's the first step. The architect will help you, quote unquote, design the house, and you will have a blueprint ready at the end of that process. So what do you do next? I kind of mentioned that already last time. I'm not sure how many people remember what I mentioned. The last thing that I said last time on Tuesday. So after the architect gives you a blueprint that you approve, okay, what would be the next step?
Getting the engineer to decide what materials to use.
Exactly. You have to get an engineer to make sure that such a structure can be built. It will have to be safe. Okay, you have to meet all the safety requirements. The material has to be available. The property, the land, has to be able to support what you want, right? Because some people may say, oh, I want my patio to extend over the cliff by 30 feet, okay, and have a transparent bottom, so people can walk out to the patio, look down, and actually see the waves crashing against the cliff. Okay, it's not impossible. We do have designs like that. The question is can the cliff material can it actually support something like that? Okay, and the engineer will probably have to go to the field, collect samples, do a lot of tests to make sure that the landscape itself is hard enough, or there are ways to remedy to make it strong enough to support a patio that is extending out 30 feet beyond the cliff itself. Okay, so the engineer has to make sure that everything is not just looking good, but it's also feasible and safe, and we can actually make it happen. In this case, when you are designing an information system, that is also the job of a systems analyst. So a systems analyst is really doing double duty as an architect and also as an engineer. Okay. All right, so let's just say that the engineer, the civil engineer, did all the tests, did all the studying, did all the calculations, okay, and say that yes, such a house, can be built at this location, and I know it's going to be safe. What do you do next? You have the blueprint, and it is already refined to the point where it can be built safely. Yep.
You have to look at zoning laws or other factors.
Okay. But I think the engineer and also the architect, I think one or both of them are responsible to do that.
Contractor.
Contractors, all right. So we are finally ready to break ground and actually start to do some work. Now, at this point, let's just say that money is not a problem, okay? How many people would tell the architect and the engineer and say, well, since both of you or both firms already know about my design really well, and I really trust you guys, how come, I want you guys to build a house for me? So you're asking your architect and your engineer to build the house, okay? What do you think of that idea? Okay, most of you are turning your heads. Why don't you think it's a good idea? They don't have the experience or the knowledge. Now, that's kind of interesting, because the engineers, particularly, they did all the calculations. They understand exactly what material to use, how many screws, how many bolts, and all the bracing, all the structural thing. They understand everything from top to bottom to make sure your house is safe. But how come you don't want these people to build the house, even though they have a complete understanding of what a house is supposed to be? Go ahead.
Their work is all theoretical.
They're all theoretical. No, it's not that theoretical, but they can tell you exactly what size of bolt nuts, what not to use. Go ahead.
The experience sort of gives you a good understanding of time and cost.
Okay.
So that's what can actually help the architect and engineer on behalf of the client.
Okay. But that's not the reason why I should not get those people the house. Okay, what tools do you think an engineer uses normally? AutoCAD, okay, calculators, okay, other types of specialized software to do all the calculations, make sure the forces all work out.
They don't have the practical knowledge of how to get their designing into actual physical form because they're used to dealing with computers. They don't necessarily know how to use a forklift or some other.
Exactly. They don't necessarily know how to use circular saws, table saws, all kinds of equipment that a contractor would have to use to build a house. Okay? Now that is exactly the reason why, even if money is not a problem, even if you say, okay, I can pay you guys, even more hourly rate, for building the house, you don't want the engineers or the architect to do it. Yep.
Another thing is if there's any complications, like say you want a granite countertop and it doesn't fit the dimension because the pieces keep cracking because of large size or something, you also need to talk to them rather than have just two people sort of figure it out themselves.
Okay. Yeah. All right. Now, so we are now getting into an area where it is kind of interesting because in computer, information system development, we have two groups of people. One group is called, or they're called the systems analysts. They will do the jobs of the architect and also the engineer. The other group is called developers. They will do the jobs of the contractors. Okay, and a lot of times, there's a confusion or there's a question of, why won't we have the systems analysts who came up with the entire specification of the system to do the job of actually writing the programs? And it's exactly for the same reasons. Okay, the tools that you need to do systems analysis are not the same tools that you need to do programming. So even though a systems analyst has a very good idea of what the finished product should look like, should behave, and how it should be specified, like how many transactions per second, and so on and so forth, they are not the right people to write programs. Okay, so the analogy is exactly the same. Systems analysts are the architects and the engineers. Developers are the contractors. They're the people who will haul in the 2x4s, the building material, the concrete, mix the concrete, pour the concrete, put in all the material in the right way. So what we'll do is, I'm going to skip this one here. You guys have to read it, but I'm going to skip it today. But we'll jump into developers. And particularly, we'll try to explain why don't we want the systems analysts to write their own programs. Now, programming, which is the focus of this class, because systems analysts don't have to deal with programming or algorithms for the most part. There are several major challenges in program development or developing a program. The first obstacle would be the syntax of a programming language, which is analogous to the grammar of a natural language. Now, I'm pretty sure my grammar is not perfect. Okay, I'm self-aware of that. But most of you probably can understand 90% of what I'm talking about in class. Would that be a fair assessment? Or is it down to 50% now? Half the time I have no idea what you're talking about. I think most people say that 50% when I refer to science fiction and other things. When I do my digression, I will start to lose people. It's like, no, I have no idea what you're talking about. Okay, but for the most part, natural languages and people in particular are forgiving. In other words, I can make a grammatical mistake, and most people can just kind of move on and still be able to understand the concept